Okay, logarithmic differentiation basically involves taking a logarithm of both sides first. All this stuff. Because then the power could come down, and then evaluating the derivative. And the chain rule would have to happen over here, because if you're trying to take the derivative, it's the derivative of the outermost function times the derivative of the innermost function. It gets pretty complicated. I think our textbook has a formula. Anytime you want to do logarithmic differentiation, you can just go to this stated fact. The derivative is equal to the original function times the derivative of the natural log of the original function. So we can just plug f in everywhere where we see it right here. If this is me, I probably wouldn't use logarithmic differentiation. We can get by without it for this problem. Just the power rule and then the chain rule. The chain rule involved with the quotient rule. Man, that's a lot of stuff anyway. Okay, let's do what they say. Logarithmic differentiation. This is a result from logarithmic differentiation. If you want the derivative, then it's the original function to the fourth power. And then we're supposed to multiply it by the derivative of the natural log. So here is what natural log of f is for our problem. It's 4 natural log 1 plus 2x squared over 9 minus 7x to the third power, because the 4 comes down. Oh wait, no, sorry. That's the natural log of f. The 4 comes down and multiplies. I haven't done any calculus. We just did pre-calculus stuff, right? They want a natural log of f. So if I take a natural log of both sides, I can use the power rule and make that 4 multiply. And now I'm supposed to say what the derivative is. So I'm supposed to take a derivative of natural log f. I'm taking a derivative of this side. If I do that, 4 is just a constant. And then the derivative of natural log is 1 over the argument, right? If you have natural log x, then the derivative is 1 over x. So this is like our big X. So if you think about it, 1 over 1 minus 2 over, that's too complicated. What's happening is you're putting this whole big fraction in the bottom of another fraction. But if you rewrite that, it's like 1 divided by a fraction. You flip and multiply a fraction, right? So if we're taking a derivative, this is just going to be the reciprocal. This is going to be 9 minus 7x over 1 plus 2x squared. Now that's a derivative. Oh, it's still multiplied by 4. I can't drop that constant. Okay, that's a derivative of the outermost function. Now I need to multiply it by the derivative of the innermost function. So that derivative involves quotient rule. The derivative of the first of the numerator times the denominator minus the numerator times the derivative of the denominator. So that's 4x. Ran out of room there. I'll remember that's 4x. And that's all being divided by the denominator squared. Okay, so the numerator, let's distribute that negative 7 to everything. And then we got a negative sign to distribute to everything, so that's going to be, and it's a 4x multiplying everything. Man, this problem's crazy. 36x, 740, 28. That's going to be a positive 28x squared all over 1 plus 2x squared. That's being squared. And then we can still clean up the numerator a bit. Combining like terms, we've got 14x squared minus 36x minus 7. Quick check to see if that can be factored. Multiply the first and the last. I don't think it can. Numerator can't be factored, I'm pretty sure. So if you multiply those together, We got 1 plus 2x squared in the denominator, and then we got 1 plus 2x squared being squared in the denominator, so that's going to make 1 plus 2x squared to the third power in the denominator. And then up here in the numerator, I'm not going to multiply that out yet. Maybe something's going to cancel. Okay, remember what all this was the derivative of the natural log. It was this piece right here. So according to the formula, it's supposed to take the original function and multiply it to the derivative of that natural log of the original function. So this is our derivative. Okay, so this is the last part we need to calculate. Do a little simplifying. Thank goodness some things cancel out here. Sort of. I've noticed with these problems in this textbook, there's way more tricky algebra than there is calculus. It's crazy. I'm just basically copying everything down right now. The only change I made was everything here is to the fourth power, so I put this to the fourth power and I put this to the fourth power. Because this and this are the same term being raised to a different power. So we got power of 3, power of 4. That brings it down to a power of 1. Power of 1 and a power of 4. This knocks it down to a power of 3. Oh, and it's gone up there because we cancel them out. We already checked. This can't be simplified, right? Can't factor this. I think we've reached the end.